Super Breakout. Super Breakout. Okay, I gotta find my Super Breakout harness. I imagine it's pretty buried. Super Breakout. Stunt cycle. Pole position. Regular breakout. Super breakout. There we go. Actually starting a job for a customer. 2 Sprint 2 boards, a breakout board, and a super breakout board. And I have found all of those harnesses. We're starting with that super breakout, so there's only one super breakout board. Super breakout. And I gotta get my glasses. Glasses. Superior breakout. Super breakout. We got volume. That's game select. Serve. Coin. Alright. And this is black and white. Black and white video. Get my meter, voltage meters, volt meter. I'm on a Mexican, whoa, radio. I wish I was in Tijuana. And this has got this goofy socket. That's going to have to go at some point. Alright. I wish I was in Tijuana. Alright, let's fire it up. It's going to be just this. Alright. We do not have sync on the video. That is parts. We got 5.8 volts, which is pretty good. .09. Okay. The voltage is a little high. It's 5.10. It's not terrible, but I do want to replace. I'm going to replace that to get that. It might be drifting high. It might continue to drift higher and higher and higher. I don't know. But I think it'd be a good idea to replace that. Yeah, I want to replace that for sure. And we got some. I need to get the schematic out and find out why we have no sync. So that'll probably be the first thing I do. Let me get out the schematic. Okay, I printed off theory of operation, made a little booklet. And I'm just going to look over the synced section of the schematic. Sync generator. Okay. I don't really care about theory right now. I just want to see the schematic. Here we go. Here's the sync stuff. So I'm going to go ahead and fire it up and turn on my little scope. Go ahead and ground that. Don't care about this right now. Everything plugged in. Okay, and fire it up. And let's find some sync stuff. N9 is the 04 that oscillates. So that is going to be this guy right up here. And I'll just check all of the inputs and outputs. Okay, that ain't looking good. What's our voltage? Yeah, 5 volts. Yeah, it's 5 volts. What is going on with... Oh, it's not grounded. That's why. It just wasn't grounded. There we go. Tell you what, I'm turning the air conditioning. I'm going to close the door and turn the air conditioning on because it's getting hot. It's going to be noisy, but it's really getting warm out today, so. Okay, still no sync on the monitor. I'm just going to check all these inputs and outputs. That's weird looking. I don't see anything that doesn't really look right there. Let's move on to R8, which is a flip-flop. look at R1. Which is a 74. And then L3 and M3. Okay, that all looks good. Then we have a sync prom at M2, which is this guy. We'll just go through the address bits. Looking good. And the output bits. I don't know about that. That looks a little suspect. Because they're not really doing anything. This one is. But it's like the least significant bit is the only bit that's really toggling. So I don't know about that. That's a question mark. And then we have signals off of N2, which is a 175. This guy right here. Clock. My suspect right now is the sync prom. And what I can do with that is analyze it and write down some of the values and then just do spot check against the actual file. So that's what I think I'll do is I'll set up and do analyzing tests on that. And just write down the values that it's spitting out at certain addresses, and then just verify it against the actual file. That way I can test it without pulling it. It's not a full complete test, but it should be enough to tell me if this thing's working correctly or not. Because all of the other sync signals look fine. R9. Let me check R9 really quick. This guy up here. Yeah, that looks fine. It is in reset. But whether it's in reset or not, it shouldn't matter. It should still it should still have here's the video signal, and it seems kind of strange that it's riding so high up there. Let's look at the video output section. Let's check that out. Find the output for the video. It is in reset, which means it's got bad ROMs or bad RAMs or a bad socket on the CPU or something like that. But right now I want to figure out why we have no static picture. Okay, here's the video output. I have L6, which is a 20. Okay, that looks good. Okay, we have a composite sync signal. Where's that come from? Now I gotta find composite sync. Here it is. R2. That's composite sync, 15.7 kilohertz. And you know, I gotta be honest, that looks fine to me. I see the vertical pulses. It's at 15.8 kilohertz, so it's right where it needs to be. So why in the world is this showing up all skewed on my picture? Is it not plugged in right? What's going on? Ground, black and white. Do we have a bad... Okay, that looks fine. Composite sync looks okay. P2. Uh-oh. Is that supposed to have a signal? Yeah, I found a dead signal. That right there, pin 3 is floating. And I believe that is supposed to be something. What's funny is on the schematic it shows pins 4, 5, and 6 of P3. P3, my bad. P3. And that's fine. Okay. That's a bad signal, whatever that is. So I need to find P2, pins 1, 2, and 3 on the schematic. What is that? So it's just a hunting game. P2. Let's find out what that is. It's a not OR gate, NOR gate. P2. Watch it turn out to be nothing. Oh, I didn't see it. Yeah, it's not on here. It doesn't show anything. I don't see it. I guess I'm just going to have to trace it. Apparently it's not on here. 11, 12 out to 13. I'm not seeing it. I don't know what's happening. I don't know what's up. How's it not on here? We're wasting some time. Wasting lots of time. Alright, I'm just going to have to turn it off and just look at that and see what if it goes anywhere. Yes, it goes somewhere. It's not on the schematic. This board looks like it's got some damage. Possibly. Oh shit, it's raining. I'll be right back. Oh my back. Alright, I'm back. Yeah, we got, I gotta find out what's going on with this. But there's a lot of scrapes and scratches on this board. Okay. I forget which pin was floating. I think it was pin 3. Pin 3 goes, where is my, I gotta go find my beeper. Okay, after looking and tracing some of that stuff out, it seems like that is not a circuit. So, I don't know. One of the floating lead leads to a unconnected output of a chip that's not even on the board. So, I guess that is nothing. That's probably why it's not on the schematic. But Boy, it's really pouring outside. The first thing I'm going to do is prep this big socket for removal. So to do that, first thing I'm going to do is solder new solder into it. And I took a quick once over on the board and I don't see any obvious damage, so just some scratches and stuff like that, but I don't think there's any real damage. You know what I need to do is make sure these pins are straight. Just make sure they're straight. Come on. This is more difficult because there's so much surface. God damn it. Yeah, I'm just going to have to solder sucker that up because it won't come off. There's so much surface on this side that it's hard to do that because there's so much surface. So it is what it is. Just a big old pile of solder there. We'll have to get it with the gun. As the gun heats up, we will kind of clean this up a bit. put this up. Alright. Now I have to go find my little needle nose pliers. I'll be right back. Okay. There it is. Still no sync, no change. But we got good power, better socket. Okay, I've been probing around the sync signal. I removed the sync transistor. This guy right here. I tested it. It was fine. I put it back in the board. I could not find anything wrong with the sync on this at all. So I got my old black and white monitor out. I unhooked this and I hooked up my old black and white monitor. There is not a sync issue. So yeah, I wasted a lot of time chasing a sync problem that didn't exist. And after I replaced the socket, after I replaced this, I got good signals coming off of my sync prom. Here's the lowest bit. Here's all the bits, the output bits. So they're kind of the same looking, actually. But that's not the problem. It was the monitor. This thing right here, I don't know. So I'm just going to have to take this monitor and pop it up here and get rid of this thing. It's a good tube. I'll keep the tube. But yeah. So, alright. Goodness. I had to flip a switch on the back of it. I don't know how that switch got flipped. There's a switch on the very back that I had to flip. So I don't know. Weird. But it works. Whatever. Moving on. Now we just have... It's in reset. So I'm going to get my 6502 pod and we'll test the RAMs and the ROMs. This has bipolar ROMs. So we'll test those all out and make sure that they're all good. Okay, I got the fluke out on it, and I've already identified the bad RAM. It has one bad RAM chip, and it's this one. And I just found that by doing the, I will show you. First off, in the theory of operation, it has your memory map. Oops. And we can do 0 to 007F is the program, or 0-page RAM. Basically the CPU scratch RAM, I guess, if you will. And then from 400 to 77FF, we have the video's display RAM. So if I do RAM, let's just do 0 to, what was it, 007F. That was the page RAM. And it gives you, and it just loop it. And you just jump the RAMs until it clears up, and it was this one. Right there. And it clears up. And then you can repeat the test, and it passes fine. Do the video display RAM. See, that's fine. We go ahead and remove our RAM and try it again. Repeat. And it gives you that RAM error. So that is the bad RAM. Now what I'm doing, these are equivalent to 82S185 1K by 4 bipolar ROMs. So each one of these is a pair for 8 bits, 1K by 8. So I'm going through and I'm doing 1K. 1K in hex is 0 to 3FF, 400 to 7FF, 800 to BFF, and then C00 to FFF. Those are 1K blocks. And the ROMs start at 2C00. So I'm doing ROM checks and I'm jotting down what it tells me the signature is, and then I'm going to go in and verify it against the actual ROM set. So yeah, and what I'll do also is I'll do a composite. I'll do a RAM or a ROM check on my Fluke from 2C00 all the way to 3FFF and get a total signature. So I might have to use that because I don't know if these 1K blocks are in MAME or if they have the 2K blocks. I don't know. So anyway, that's what I'm doing now is I'm jotting down the signatures that it gives me so that I can go back and test them and see if they're actually correct. Okay, so after doing some investigating, I found out that I do have a bad ROM, at least one bad ROM. Now, I verified that this is fine. 2C00 to 2FFF was okay. The bad range was 3000 to 3FFF. That's the one that is no good. So I need to figure out which range is that. Which two chips is that range? Because I need to replace at least one of these chips is bad. And it'd be great if it's just a socket, if it's one of these. So I think I'm going to fire this back up and just see if I can manipulate the bits and try to find out what this range is. Okay, so I was able to get the ranges on these just by using a logic probe and probing the selects whenever it was trying to read those ROMs. Pretty simple. I'll give you an example of that. Atari almost always has a ROM range that rests in the low state, like this. And it's usually the highest range. And this is the highest range. And this makes up, because these are 4-bit parts, so this makes up 8 bits. This is 1K of 8, 1K by 8. And this rests in the low position. And when the system activates another ROM, this will go high as this goes low. So it's just disabling this to enable another one. And if we do 2C00 at 2FFF and read that range, that's these two chips right here. And loop. Now this is going to be active. And this is going to be active as well because it's disabling. That's interesting. See how it's high? That means it's usually resting high. So it's pulsing with the high light on. And this one is usually resting low, so it pulses with the low light on. Pretty interesting. So it's like this normal state is low and this normal state is high. Anyway, that's how I figured out what was what. So let's go ahead and just stop this. So I went ahead and I found the ranges. I wrote the ranges on my Super Breakout sheet and the Fluke signatures minus these two chips right here is the range that's in question, and luckily they are socketed. So what I'm going to do is just get my reader out, dump these two files. These are 82S 137s. I know I stated that they were 185s earlier, and they're not. They're 137s. These are 1K by 8. A 185 is actually 2K by 8. So yeah, these are 137s. So I'm going to dump both of these, and I do have these ROM files. I saved them at a previous date. These are not in MAME. This set is not in MAME. MAME has the 3-chip set It doesn't have the bipolar set. So, yeah, I'm lucky that I did save these. So I do have these files. So I'm going to go ahead and dump both of these and find out which one of these, if not both, is bad. So I'll go ahead and do that. Alright, after dumping these two chips and checking them, they both verify to what I have. So I'm thinking we might have socket issues. So I'm thinking I'm going to replace all of these sockets. These 5 sockets. Because if these two are bad, chances are the other 2 are no good either. So just for the sake of what am I looking for? Oh, I don't know. The sake of not failing. Can't think of the word right now. My brain's not working. So I'm just going to replace these sockets. Alright, I got new sockets in the board. I replaced this RAM. I got my CPU installed. I looked up the dip switch settings because I wanted to set it to English, 1 coin, 1 credit, and extended play at 2000 with 3 lives. That's how I set it up. So let's go ahead and fire it up. And it is now running. So yeah, it was just a bad socket, but it's definitely got issues. There's graphic problems. Those walls are not supposed to be dotted. And it's saying 1 coin 2 plays. I thought I set it to 1 coin 1 play. And there's like little graphic glitch. I set it to 1 coin 1 play, I thought. One coin, 1 credit is on, off. 1 coin, 1 credit. One coin, 2 credits, the exact opposite. On, off. Yeah, it's now it went to French. And it's still in French, and now it's really goofy. I think I've seen this before too. This dip switch is probably no good, so I'll probably end up having to replace that. And it's still in something. I don't know. Alright, yeah, we're going to have to swap out this dip switch. Oh, I saw it flash. It's flashing towards English. Yeah, this dip switch is no good. I need to replace that. So, okay. Dip switch, and then we've got some graphics issues we'll have to find. And we might have bad. I mean, it's possible that these sockets are no good. Oh yeah, see, yep, this one's no good. I touched this, and now the balls look normal. Well, I don't know if that was just a coincidence, to be honest. Yeah, I don't know. Anyway, I need to replace that. I might as well do that. And then we'll move from there, I guess. Yeah, I just removed this chip out of the socket right here. And it made the balls do that. And they were kind of going between that size and the correct size. This socket is bad. These sockets are garbage. If these sockets are the same sockets, I'm going to replace those too. I don't know if they are or not, but I need to look at them. These bipolar ROMs create a lot of heat and they just lose connection. So that needs to be replaced. That needs to be replaced. And if these are the same sockets as that, these sockets are going to be replaced. Alright, I got it all back together after replacing the sockets, and I actually put a socket here so I have the dip switch in a socket. And it still says 1 coin 2 play, but it's at least in English. But the ball looks really goofy because I put this darn chip in backwards. This is a graphics ROM for the ball, and I put it in backwards. So honesty is the best policy. I killed that chip. So I owe customer that chip free of charge because of my goof up. So I want to mess around and find 1 coin 1 play. Because obviously the dip switch settings aren't correct, obviously, so I don't know. On maybe. Bonus for 2,000. Maybe on is free play. I don't know. It's not going into a track now. Let's try off. That's 2 coins 1 play. Let's try off on. There's 1 coin 1 play. It's off on, so it wasn't correct in the whatever. So I gotta program this or bipolar so that we get the ball back. And then go from there. And I'm done for the night. I'll do that tomorrow. And yeah, that's unfortunate, but it is what it is. So tomorrow, I'll program that chip, and then we'll start in on the side. The sides are all dotted, and they're not supposed to be dotted. See that? That is incorrect. So there's graphical issues. And I'm wondering if that's another bipolar ROM. There's 2 here. There's another one somewhere. I don't know. There's a handful of them. There's a few of them on this board. That might be the only 2 that are left. But I'll get into that tomorrow. I don't want to mess with it anymore tonight. So, alright, we'll see you tomorrow. Okay, I have removed these 2 ROMs right here, bipolars. They're right there. One of them, one of the legs broke off of one of them. So, and interestingly enough, one of the legs was folded over when it was put in here. I don't think it was a problem. But over time, could that have lost connection? I don't know. One of the legs was folded over on this chip right here. So I straightened it out. But I'm going to put sockets in here. I want to test these and make sure that the make sure that the files are correct. I'll reprogram this guy and go from there. I know these are playfield ROMs, and remember how we had the dotted pattern on the border? That could be an issue with these. I want to make sure and verify that the ROMs are good before we start checking logic. So that's how we're going to get at this. So let me go ahead, put a couple sockets in here, get the programmer back out, read these, verify them, program this guy, and we'll be back in business. Alright, this is file P4. That's what I named it, 512byte.p4. And if I verify it, it does verify. So if I take that one out and put R4 in, and let's do R4, which is going to be 512byte.R4. Load that up. Okay, and then try verifying that one. It does not verify. That's good news. That's a bad ROM. So that one, R4 is bad. So I'm going to program a new R4. This one is fine. That's P4. And then program another 123 for that other chip. All right. New 82S131 programmed. Got an AMD 27S19. Okay, now I need to load that file. So let's go to load. It's going to be 32byte.k6. 32byte.k6. There you go. And program. Done. All right. Here we go. Thank you, programmer. Appreciate it. All right. I got these back in. They are in the right polarity. No backwards parts. So let's see what we got. All right. Good. You think it'll fix the border? It did. Yes, 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 yes. There you go. Our graphical problems are fixed. Let's put this thing into test. It does some really annoying sounds and stuff. Yeah. See if our spinner works. Oh, I can't see. Is it working? Yeah, it's working. It's enough of that. Alright, yeah, let's set up camera on the tripod and do a little bit of testing. Okay, we got her running. Alright, how's this work? PCB, I don't know. Let's just give it a shot. One coin, so we'll coin up. And we're on, the game selector is on P, whatever that means. We'll figure it out eventually. And here is serve. The paddle works. I hit serve, right? Serve isn't working? Is that what you're telling me? What's going on? One coin, one player. Yeah, serve isn't seeming to work. Here is C, P. Oh, P is progressive. The serve button does not work. Okay. Paddle works good. The paddle works really good. D must be double. So D stands for double. P is progressive, where it actually comes down at you. And then C is like this is C, whatever that stands for. I don't know. Okay. But serve isn't working. We can't play if we can't serve. Alright, so we got to figure that out. Let's just get this back over here. We can't serve. If we can't serve, we can't play. So, back to Mr. Schematic. Apparently it works fine. I got to looking at the schematic and I'm like, oh, there's a start button. And I had buried underneath the connector start. So you have to hit start before you hit serve. So let's put the camera back on the tripod. Try it again. Duh. Alright. You know what? Let's turn the lights down. Get that dramatic effect. And let's give it a shot. Alright. Game is started, so I can just hit serve. And try to count's correct. I'm paying attention to the count. Alright. Well, let's try it again. Alright. Coin. Where's coin? Coin. Start. Serve. Let's see, we have 1, 2, 3, 4, 5, 6, 7 blocks gone, and those are all 1-point blocks. And our score is 7. So we're looking good. And I know I saw, here's a 3, no, 8, 9, 10, 11, 12, there's a 3, 15. 17, 8, nope, 20. 3-pointer. Yeah. Alright, let's move on to the next. Well, I gotta finish this game. We'll move to a different game. We'll move to cavity game. Oh, that is cavity. This is progressive. So let's try progressive. Coin, start, and serve. I'm just terrible. I can't hardly play it. The paddle works excellent. I can't even get to a progression. Alright, let's try the next game. Double. Alright, coin, start, serve. Yeah, let's try that again. Yeah, I'm not good at this. There you go, fellas. Superior breakout. Super breakout. Super breakout. Lights. So, repair, recap. Repair, recap. Sockets were bad. I replaced all of these sockets. All of the old sockets are gone. Had a bad ROM right here. I killed that ROM, replaced it. Dip switch was bad. Replaced the dip switch. Replaced the regulator, get a better regulation. Replaced that socket. And by golly, I believe that's it. Did some resoldering up here, make everything look a little bit better. Oh yeah, had a bad RAM, remember? RAM. And that's about it. So, that's how you fix a super breakout board. I'm going to give a shout out to my friend Todd. I have a Patreon member named Michael who picked up a Battlezone game that was virtually complete, minus a handle grip for the button, the right side handle grip that has the button on top for firing. Michael sent me pictures of his Battlezone game, and I complimented. I was like, wow, that's awesome. What a great pickup. He got it cheap. And I noticed he said that it's completely complete and in good condition other than that pistol, that handle grip. And I said, well, I know someone who might be able to hook you up. And I contacted Todd. And I asked him, do you still have some of those Battlezone grips? Because I knew he had some years ago. And he said, yeah. And he showed me a picture of them. And I was like, awesome, man. How much do you want for one of those? And for just the handle, the little plastic button, and the silver little beauty ring that goes with it, and the screws that hold it together, I asked Todd, how much do you want for them? I got a friend, a Patreon member, who had picked up a Battlezone that's just missing that. And he said, you know what? Just cover the shipping and it's his. So, you know, that's a big shout out for Todd for that. Because those things, I know, they can get a pretty penny, you know. And he just generously gave it up to Michael, and I really appreciate that. Michael appreciates it, and just big shout out to Todd for doing that. Appreciate it. So now I'll put up pictures, some pictures of Michael's game that he grabbed. And I took a picture of the pistol, or I keep calling it a pistol, the handle grip that Todd sent to him free of charge, just shipping. So yeah, really cool. Big shout out to Todd and Michael. So anyway, that's going to wrap this one up, Super Breakout. And you know what's funny about this Super Breakout board? This was sent to me by a guy local to me, relatively speaking, in the same state anyways, maybe an hour or two away, hour and a half. But I don't know if he knows this, but back in the 2000s, Todd, the owner of this board, and I used to go to auctions together back in the mid-2000s, 2005, 6, 7, that era. I don't know if he realizes that I'm the same guy that he used to hang out with. So, Bob, how you doing? Been a long time. I'm very happy to work on your stuff. I'll be getting a hold of him to formally say, hey, you know, you remember we used to actually hang out a little bit. So yeah, I just thought it was kind of cool. And Todd wants your contact info. All right, guys, that's going to do it for this one. We will see you on the next Classic Arcade Repair. Bye for now.